This lesson is on evaluating limits by looking at graphs. So let me go ahead and pull up Desmos. So I have this function here. And let's say I want to know the limit as x approaches 0 of this function. So that's the question we're going to ask. What is the limit as x approaches 0 of f of x? So as the x values get closer and closer to 0, what do the value of the functions get closer and closer to? So we can blow this up. As the x values get closer and closer to 0 from the right, what's happening here? It looks like it's getting closer and closer to what? To -5. So as I'm scrolling in this way, I'm choosing numbers to the right of 0, -0.4974, -4978, -4988. As I approach from the right, the limit as x approaches 0 from the right of f of x seems to be what? Seems to be -5. As we're scrolling in this way, the y values, the values of the function getting closer and closer to -5. So we know that. Is the same thing true as I approach it from the left? As I approach from the left, now I'm approaching 0, the x value. That's what you want to think about. Notice my x value is -0.33, -0.25. I could zoom it in more if you want, even. Right? As I move this in, what are the y values getting closer and closer to? Again, getting closer and closer to -5. So the limit as x approaches 0 from the left of f of x also seems to be -5. They are the same. So the limit exists. And what do we say? The limit as x approaches 0 of f of x seems to be -5. Now you'll notice I could have just plugged 0 into the function, right? If I plug 0 into the function, it lands at -5. So in this case, the value of the limit and the value of the function are the same. So f of 0 is -5 according to this. So that tells us something about the continuity of this function. But now I'm interested in what's happening here at 3. You'll notice I have a hole at 3. So that's going to be our next question. What is the limit as x approaches 3 of f of x? So we're going to approach from the left, we're going to approach from the right, and we're going to see what happens. Again, this is our question. Limit as x approaches 3 from f of x. So I want to look to see what happens as I approach 3 from the left. I want to look what happens as I approach 3 from the right. What do those y values go to? So let's look. As I approach 3 from the left, so pick points here, 3.451, 3.567, 3.6. Where is it headed? Where are the y values headed? They sure seem to be getting closer and closer to 4. If you want, you could again zoom in, right? Just to see a little bit more. What are the y values getting closer and closer to? As we approach 3 from the left, the y values sure seem to be getting closer and closer to 4. So that's what we say here. As we approach from the left, they're getting closer and closer to 4. Let's see what happens as we approach from the right. So again, here we are in this function, approaching from the right. Number's bigger than 3. What are the y values? The y values are shrinking, getting closer and closer to what? Getting closer and closer to 4. So they're the same, so the limit exists. We know that, and we're going to say then that the limit as x approaches 3 of f of x without the minus or plus just equals 4. But I want you to notice something. There is a hole on that graph, right? If I choose, turn the label off. I guess I can't. Maybe I can. Let's see. We're going to go to the original. So here's my original graph. I have 3, 4. I have a circle there, but my original function is not defined at 3. You'll notice that. So if I get there, it says 3 undefined. It doesn't show you the open circle, which is why I had to program it to show you that. But 3 is not actually on the graph. Let me see if I can stay there. There we go, 3 undefined. So there is a hole on that graph. So the value of 3 doesn't exist. I emphasize that by putting that hole there. But the limit does, because what the limit is concerned about, what happens near the graph, not what happens at the graph. So we're going to look at a different function now, and I want the limit as x approaches -2 of f of x. And here is our graph here. So as I approach -2 from the left, what happens? As I approach -2 from the right, what happens? So let's see, as I approach from the left, the values of the function are getting closer and closer to what? It looks like it's getting closer and closer to 2. We're approaching -2 from the left. It looks like the y value is getting closer and closer to 2. As we approach -2 from the right side, the y values also seem to be getting closer and closer to 2. So looking at our picture, limit as x approaches -2 from the left of f of x, looked like it was getting closer and closer to 2. Limit as x approaches -2 from the right of f of x, looked like that was going to be 2. Therefore, the limit exists because they're the same. And then what do we say? We say the limit as x approaches -2 of f of x equals 2. We see that from our picture. Now, what's happening at -3? As I approach -3 from the left, as I approach -3 from the right, what is happening to the graph? So that's our next question. Limit as x approaches -3. Of f of x. So I want the limit as x approaches -3 from the left. And I want the limit as x approaches -3 from the right. What is that going to give us? So looking at our picture, as I approach -3 from the left, the y values just keep growing. I approach -3. I'm all the way at 39 or 40. As I approach from the right, same kind of thing happening, right? As I approach -3 from the right, the y values just keep growing and growing and growing. But you can sort of see that from the graph. As I approach -3 from the left, it goes to infinity. As I approach -3 from the right, it goes to infinity. So fine, we can say it equals infinity, but please do not think that that exists. It doesn't exist. As we approach -3 from the right, it also tends to go to infinity. So I will say then that the limit as x approaches -3 of f of x does not exist. It is not a real number, but it is tending towards infinity, which is why this notation is often used to say that the limit as x approaches -3 of f of x in this case does equal positive infinity. Because looking at the graph, heading from the left, it goes to positive infinity. As x approaches -3 from the left, the y values approach negative infinity. As x goes to -3 from the right, the y values approach negative infinity. So we're going to look at one more graph here, and we're going to start with limit as x approaches 1 for f of x and the limit as x approaches 7 for f of x. Let's look at our graph. Here it is. Now notice this does pass the vertical line test. These pieces are not connected. That's okay. But the solid dot is here and the open dot is here, so a vertical line still only hits it in one point. And I want the limit as x approaches 1. As the x values get closer and closer to 1, what are the y values getting closer and closer to? X values closer and closer to 1. Y values from the left getting closer and closer to 3. Y values from the right getting closer and closer to 3. So let's go ahead and say that. Limit as x approaches 1 from the left of f of x seems to be 3. Limit as x approaches 1 from the right of f of x seems to be 3. So if that's the case, then the limit as x approaches 1 from f of x exists. And the limit as x approaches 1 of f of x equals 3. We get that. How about the limit as x approaches 7 of f of x? Let's go back and look at that. So we're approaching 7, getting closer and closer to 7. What are the y values getting closer and closer to? Looks like they're getting closer and closer to 2. Approaching from the right, what are the y values getting closer and closer to? Looks like they're getting closer and closer to 2. Okay, from the left and from the right, it looks like things are getting closer and closer to 2. Limit as x approaches 7 from the left of f of x seems to be 2. Limit as x approaches 7 from the right of f of x seems to be 2. Therefore, the limit as x approaches 7 of f of x exists. It's an arrow there. And the limit as x approaches 7 of f of x looks like it equals 2. But what is the interesting point on this graph? Of course, what's happening at 2. So what is the limit as x approaches 2 of f of x? That's what we want to know. Limit as x approaches 2 of f of x. As the x values go to 2 from the left, what happens? So we're going to want to know that. What is the limit as x approaches 2 from the left of f of x? And what is the limit as x approaches 2 from the right of f of x? That's how we have to start our analysis. From the left, approach x to the left of 2. So left of 2 is here. Where are the y values heading? 3.964, 3.986, 3.99. It sure looks like it's getting close to 4. In fact, it lands at 4. But from the left, the limit as x approaches 2 from the left sure seems to be 4. How about the limit as I approach 2 from the right? To the right of 2, I'm over here. To the right of 2, where are the y values headed? It looks like they're headed to -3. Now, they never actually get there. We have a hole there, but it gets pretty close. So what happens at 2 is irrelevant. What happens near 2 is what I'm interested in. And near 2, it looks like the values of the functions are getting closer and closer to -3. They are different. Since the limit as x approaches 2 from the left of f of x does not equal the limit as x approaches 2 from the right of f of x, we conclude that the limit as x approaches 2 of f of x does not exist. And that'll tell us something about continuity. If the limit doesn't exist, the graph can't be connected. But notice we have a gap. It's more than just a hole. This is a gap. This is a special kind of discontinuity we'll talk about later.